Smith chart by the characteristic impedance value, which is given in the which would be given in the question, and you have to take the actual admittance value. Oh, if the value of the characteristic impedance is not given, you can write that you are assuming that the value of characteristic impedance is 50 ohms, then you can multiply from that value. And then you have to find the VSWR value. Then you have to find the input impedance of the line. So input impedance of the line, you can find like when you know the length of the line. So if the length of the line is like let's say it's 0.1 lambda, and then you know the point where the load is, right? From the load, you have to find towards the source, right? Right. The input point is somewhere somewhere I mean at a point where you will be traveling towards the source. So in the Smith chart, like from the load point, you have to travel towards the source to find the input point. So you have to travel a 0.1 lambda distance to find the input point. So in the Smith chart, you can find a certain scale, which is given as wavelengths towards generator, right? It's given in the outermost scale. So using that scale, you can measure a distance of 0.1 lambda, and then you can go to that point and mark that point. So let's say the 0.1 lambda point will come here, and then you have to connect that to the center of the circle, and then you have to project the load, the radius to the load towards to the new line that you have drawn, and then you can find the intersection point, which would give the input impedance of the line. So basically, you are projecting the load point towards the new location with the same radius. So the new location can be found using the outermost scale, which gives the wavelengths towards the generator. And source or generator, we can say here. And then we have to find the distance to the voltage minimum and voltage maximum. So voltage minimum occurs at a situation where a short circuit happens, right? So the short circuit happens in a Smith chart on the leftmost side in the x-axis. So in the horizontal axis. So the voltage minimum occurs here. So currently we are at the load point. So from there, when we are going towards the source, we will be able to find the voltage minimum value. So the distance that we have to travel must be found using the scale that I mentioned previously, the scale that shows the wavelengths towards the generator. So you have to measure this distance from the load point. You have to measure the clockwise distance to the voltage minimum point, right? And then voltage maximum point occurs at the open circuit case, right? Voltage maximum occurs in here where the open circuit happens, and then you have to find the distance from the load point towards this maximum voltage point by using the scale in the Smith chart. And you can find that using the scale, and in terms of wavelength, right? In terms of lambda, you can find that distance. If you know the value of lambda, you can substitute the lambda to that, and then you can find the distance in meters. So basically, you have to use the wavelengths towards generator scale to measure the distances that I mentioned here. And then, in the transmission line, to measure distances, you can use that scale. The VSWR value you can find using the VSWR scale in the Smith chart at the bottom, or else you can just project the load point towards the horizontal axis, and then you can find the magnitude from the center towards that point, and then you can use the VSWR scale to and then you can keep the compass one end of the compass at the center of the VSWR scale, and then you can keep the other end at the length that you measured here, and then you can find the VSWR, corresponding VSWR value. So it could be, so VSWR value is given in the first scale here. So from the center, you can measure towards this, towards the left side, because we are going towards the generator. So you can find some value which would be like between these values with, from 1 to infinity. So you can basically use the VSWR scale. And then you have to verify the above solutions using the analytical calculations. So I mentioned the analytical equations in this third question. So you can use those equations to verify the solutions we got from the Smith chart.